Okay, hi everyone. Today is kind of a funky day because when I was doing this live stream this morning, I had a slight connection problem. So if you find yourself experiencing the same problem, I'm not sure whether it's because of my own internet connection or whether it's in general. But if you find yourself facing the same problem, don't worry. Just try to follow the lesson as much as you can. And if you find that it's a little bit stuck here and there, you can always refresh, or you can change the resolution on your video so that you can view the videos a little bit better. Okay, so I hope you guys are okay wherever you are. I hope you're all still feeling staying safe and healthy. Although these few days it has been very hot, the rain is not really helping that much. But let's be thankful, okay, that we can still, we still have our life and we can still breathe and we still have our breath. Okay, so today we're going to be talking about the second last subtopic in our chapter, which is impulse and impulsive force. Okay, so we are building up from everything that we have learned from before this to this part, and then of course we're going to finally end with a very strange subtopic that is put at the end. I also am not sure what they are thinking, but today's subtopic will be actually very short. Okay, I don't think that we will go more than an hour. But it requires us to remember everything that we have learned before. Okay, so if you remember all the things that we have learned before, we have been talking about momentum, we have been talking about force, we have been talking about net force. Okay, and then of course, you also need to remember Newton's first and second law. Okay, these are the two important laws that we've been talking about, and today we're going to complete it all by finishing with the third law of motion. Newton came up with three very important laws of motion. Okay, hukum gerakan Newton. He came up with three very important laws that actually basically defines everything that we do in what we call classical physics. Okay, so today we're going to be exploring the third law. Okay, the first law has to do with inertia. Okay, then the second law has to do with force. Okay, force, mass, and acceleration. Okay, and then today we're going to look at the third law. All right, so I'm going to share these slides with you all. I hope you can see it wherever you are. Okay, and so let me see. Okay, yes. All right, so today we're going to be talking about impulse and impulsive force. Okay, I want you to consider this situation now. Now, whenever there's an accident happening, when there are two things colliding, previously we call this a collision. Okay, and we've been talking about collision dari sudut momentum. Okay, we've been always talking about momentum. When two things collide, okay, and then after the collision, we have been talking about momentum and the principle of conservation of momentum. So in the case of an accident, this is a very classic case of inelastic collision. Okay, the total momentum after the collision is zero because both are not moving. Okay, I mean, if both these cars are moving after the collision, then something is wrong. But in a normal accident like this, okay, we find that the total momentum they had before is zero, and the total momentum they had after is also zero. So all this is the momentum talking. Okay, but now we're going to be talking about the force that is involved. Okay, because when two things collide, there is going to be a force that is acting on one another. This red color car is mengenakan one force on this green color car, and this green color car, I'm going to change color. This green color car is mengenakan satu force also on the green color car, on the red color car. Okay, so the force that is acting on one another can cause severe damage and injuries. Okay, this is very normal. It's not something that I wish would happen to anybody, but in an accident, definitely there'll be some damage to the car and obviously injuries to the person. Okay, now this strong force that is acting in a short time interval, okay, is known as the impulsive force. This is what we want to talk about today. Okay, and an impulsive force is a strong force. So far, before this, we've always been talking about force as in Changing color again. Force as in F equals to ma. Okay, force equals to mass times acceleration. This is from Newton's second law. Okay, but what if we have a very big force that acts in a very short time interval? Okay, for example, two cars crashing. Two cars crashing takes less than 1 second, 0 point something seconds usually when they crash. Okay, if a car crash happens in 1 second, it's a pretty long time for it to happen. 1 second is actually a very long time in terms of a car crash. Okay, a car crash is just a snap of a finger, less than a second, it is done. So we call this time interval a short time interval. Okay, jangka selah masa yang sangat pendek lah. Okay, but in that small amount of time, okay, there's this huge amount of force, okay, that is acting on one another, and that's obviously why the cars will be, the cars will have this damage and everything, and of course, things happen, inertia happens, the guy gets thrown forward, yada yada. Okay, this one we've discussed before, but today our focus is just this impulsive force. Okay, the strong force that happens in a short time interval is known as an impulsive force. So the first thing we want to do is we want to start from here, F equals to ma, and we want to derive an equation for impulsive force. Okay, and how we do that, okay, is as follows. Okay, so I hope you can see this. Okay, so what we have here is we have Newton's second law, okay, which is F equals to ma. Now, when we were doing acceleration before this, okay, we studied that acceleration is actually the final velocity minus the initial velocity over time. Okay, so now what we do is we substitute the a into here. Okay, this derivation is very important. You need to know this. We substitute the a into here, and what we get is F equals to m, okay, and then v minus u over t. Okay, so far so good. We put the a inside here, and then we get this lah. Okay, let's expand this and see what we can get. We get, okay, mv, okay, minus mu, and this m doesn't multiply with the t, people. This, okay, leave it alone, over t. And we find that this is a very important formula for us because it tells us two very important things. Okay, the first one is it is answering this question that I posed earlier, okay, which is derive an equation for impulsive force. So this formula, okay, this formula is the formula for impulsive force. Okay, it is a strong force that happens over a short period of time. Okay, short period of time, you have a strong force, and this is called an impulsive force. The definition for this, okay, this is what I want you to notice. If you notice, mv and mu, okay, mass times velocity minus mass times velocity. Where have we seen this mass times velocity before? Okay, we did it in two subtopics ago. Okay, mass times velocity actually is equals to momentum. Okay, momentum is mass times velocity. So this final momentum, which we call, okay, final momentum minus the initial momentum, okay, over time, is also known as the impulsive force. This final momentum minus this initial momentum, okay, I'm going to call this as change of momentum. Okay, I'm going to call this as that change of momentum. Just like before this, now when we were doing acceleration, right? V minus u, final velocity minus initial velocity. This is the change in velocity, or change of velocity. I'm going to use of lah. Okay, change of velocity. And if you remember the definition for acceleration, the acceleration is the rate of change of velocity. Okay, kadar perubahan halaju, because it's divided by time. Okay, just in the same way, impulsive force, if the top here is the change in momentum, okay, the actual definition for impulsive force is the rate of change of momentum. Kadar perubahan momentum. Okay, so the rate of change of velocity is acceleration, okay, which we studied a long time ago. And now the rate of change of momentum, okay, final momentum minus initial momentum, okay, gives you, okay, the impulsive force. And that's the first thing that I need you to know. Okay, the definition of impulsive force is the rate of change of momentum, okay, which is a strong force in a short amount of time. That one we'll talk about later. Okay. Secondly, we can actually derive the formula for impulsive force from Newton's second law formula, which is F equals to ma. Okay, I substitute A in, I get this, then I find that mv minus mu, which is why we need to remember mv and mu is actually momentum. Final momentum minus the initial momentum over time. Okay, and that is called a change of momentum. So the rate of change of momentum is called the impulsive force, which is answering this question that we are talking about here. Okay, derive an equation for impulsive force. So we find that we find that the formula or the equation for impulsive force is F equals to mv minus mu over t. Okay, that's the first thing that I need you to know. All right, let's continue. So what is the meaning of impulsive force? Okay, it is the rate of change of momentum, as I said. Okay, or it is also known as the force that acts in a short amount of time, okay, during collisions or explosion. So impulsive force is something that happens during collision, okay, or during explosion. Something that we have been talking about in the past few subtopics. Okay, we don't really talk about impulsive force when we are talking about pushing something, over a long period of time. No, usually when we talk about impulsive force, it is a force that happens in a short amount of time. Okay, when the time is short and the collision happens, then that force there, we call it the impulsive force. Okay, now from this equation that we've just derived just now, okay, in this question over here, okay, let us derive an equation for the change of momentum, just the change of momentum. Okay, so I'm going to come back to this. Sorry. Okay, so I'm going to come back to this. We have this one, the rate of change of momentum. So I just want to know what is the formula for the change of momentum. How do I change this? Okay, so that I only get the change of momentum. Okay, so change of momentum, I can change color, I can change to black. Oh, sorry, not black one, this is blue. Okay, if the rate of change of momentum is the impulsive force, let's bring up the T to the other side. So Ft equals to mv minus mu. Okay, and I've already said that actually mv minus mu is known as the change of momentum. Okay, the change of momentum. Now, the rate of change of momentum, okay, kadar perubahan momentum, the rate of change of momentum is known as the impulsive force. Okay, but the change of momentum, just the change of momentum alone, okay, is known as the impulse. Okay, and there are two ways for us to calculate impulse, depending on the situation that they give. Okay, if they give you the momentum, then impulse is the change of momentum. Okay, another way to find out what impulse is to multiply the impulsive force with time. Okay, so there are, I would say, two definitions, but actually this book gives us one only. Okay, the actual definition for impulse is just the change of momentum. But another way that you can write it is this product, product, okay, of impulsive force and time. Okay, that is the other way that we can also calculate impulse. So there are two ways to calculate impulse, either using change of momentum or using force, the impulsive force multiplied with the time. But everything that we are doing here, okay, starts with this one. Starts with this formula. Okay, the Newton's second law, F equals to ma. Okay, but from this law, okay, we are learning two new formulas, two new things per se. Number one is, what is impulsive force? Rate of change of momentum. What is impulse? Impulse is the change of momentum or the product of impulsive force and time. This is very rarely used because this is more popular. Okay, the change of momentum is known as the impulse. Okay, so new words for us: impulsive force and impulse. Okay, but that's what it means in physics. Okay, so what is the meaning of impulse? Impulse is the change of momentum. And I have just shown to you over here, okay, the formula that is involved. So these are the basic two formulas that we're talking about today. Okay, but the implications, okay, the implications of these two formulas are actually very important for us. Okay, they allow us to also consider many things when we are building things, when we are considering things like how to make cars go faster, how to make things go slower. Okay, and impulsive force we find can be beneficial and can be harmful to us. Okay, depending on what is the situation. Okay, so this brings us to Newton's third law of motion. Now that we've talked about impulsive force and impulse, so we find that this car is mengenakan one impulsive force to this green car. Okay, and we find that this green car is also mengenakan the same amount of force, okay, to this red color car. Okay, and this brings us to Newton's third law of motion. Newton's third law of motion states something that is very simple, very profound, but actually it is true. For every action, okay, there is going to be a reaction that is of equal magnitude. Equal magnitude means sama besar. Okay, if I punch somebody with the face, with a force of let's say 10 newtons, that somebody's face, okay, is going to mengenakan the same force to my hand, okay, with the same amount of kekuatan, okay, same magnitude, but in the opposite direction. Okay, the best way that you can demonstrate this, okay, the best way you can demonstrate this is by leaning on the wall. Okay, let's say for example, I'm leaning on this wall like this. Okay, so my body weight, let's say for example, my body weight is about 80 kilograms, so it's about 800 newtons. So I am putting an action on the wall. Okay, I'm putting an action on the wall. So the force that I'm putting on the wall is 800 newtons. Okay, so why is it that if I'm putting a force on the wall, why is it that I'm not falling through the wall? Okay, it is because the wall itself, okay, is pushing back. Okay, is pushing back at me with the same amount of force. Okay, 800 newtons, but in the different direction. Okay, which is negative 800 newtons. So mine is positive 800 newtons. The wall is pushing back at me with negative 800 newtons. That's why I'm balanced. Okay, I'm balanced, and you don't see me falling through the wall. Okay, so what if what if the wall suddenly decides okay, suddenly my wall decides oh, I cannot give that much. I can only give you maximum 600. Okay, what's going to happen to me? I'm going to fall through the wall. Not balanced. I'm not getting an equal and opposite reaction. Okay, but thankfully, Newton's third law tells us that whatever action you do, okay, whatever force that you give to something, okay, that something will give you back the same amount of force. Okay, for every action, okay, for every force that you kenakan, there is going to be an equal and opposite reaction. Okay, so I don't want you to confuse now with, okay, I want to go back to the first, this one that we've been talking about. When we talk about the accident, okay, now let's break it down and consider just the red color. Okay, so we find that, okay, we find that the red color car is putting a certain amount of force on the green color car. Okay, and we're going to call this force F1 . Now, Newton's third law states that when this car bangs this car, okay, he is going to mengenakan another force in the same direction, which we're going to call as negative F1. Okay, that is not to say, that this green color car is not putting its own force on the red color car. It is. Okay, it may lah, depending on the situation, it may. Okay, but the green color car actually is putting his own force, especially if the car is moving. Okay, the car is putting back his own force. Okay, but Newton's third law states that whatever force that this green color car is giving to the red color car is going to be returned back to the green color car. The reaction, okay, which is the force of negative F2. Okay, thank God lah. I think in a way, thank God that Newton's third law exists. Whatever action you give, okay, there's going to be a reaction. And we find that everything balances itself out. Because now, if this was an unbalanced force situation, we talked about this in 2.6. If this was an unbalanced force situation, okay, the two cars won't be stopping. Okay, the two cars may probably skid on and on. That's a situation of unbalanced forces. One force is mengenakan a bigger force than the other one. Okay, but since we find that both cars, they bang and then they stop. Okay, let's assume that they stop lah. Okay, I know in real life situations are very, very different, but let's assume that they stop. Okay, we find that in any case, whether they're stopping or they're not stopping, Newton's third law still works. Okay, Newton's third law still works to show us that when there's an action, there is going to be an equal and opposite reaction. There must be an equal and opposite reaction. Okay, otherwise, many things won't make sense. Okay, so we call these two forces. I think our textbook tells us we call these two forces. One is an action and one is a reaction. Okay, and this all has to do with impulsive force. Okay, whenever there's a big action, there's going to be a big reaction. Okay, whenever there's a small action, okay, let's say you just swat a fly, so the reaction will be very small. Okay, so the problem is this, not the problem is this. The thing is this, how do we change it? What do we change? Okay, what do we change? In order to get a big reaction, we need to change the action. Okay, so let's talk about this. State two physical quantities which can produce a large change of momentum or impulse. Okay, if we take a look back at our formula that we have looked here. Oh, sorry. Okay, now we find that the impulse depends on two things. Okay, it depends on number one, the force. Okay, and number two, the time. Okay, the amount of time. The bigger your amount of time, then your change of momentum will be much bigger. The bigger your force is going to be, okay, then you find that the change of momentum is going to be bigger. Okay, so the two physical quantities that actually produce a large change of momentum is a large force and a large amount of time. Okay, the more time you take with that big amount of force, you're going to produce a big change of momentum. Okay, I'm going to specifically talk about impulse first. I'll talk about impulsive force in a while. Okay, but impulse is actually decided by two very important things. How much force you put into it and how much time, okay, you put into doing that amount of force. Okay, for example, if I'm going to, I think I have this example here. Hold on, let me show. Oh, sorry. Okay. I think it is. Yes. Okay, so explain why the football player throws the ball shown in the diagram. He has to put his hand at the back. Okay, no football player is going to throw the ball like macam begini macam tu tiada. Okay, he starts right from the back okay, because we find that he needs to increase the amount of time he's throwing that ball. Of course, the force comes from his body, but what he can change is the time that he's throwing the ball. If he throws the ball, say for example, if he's throwing the ball from just above his head, okay, just like that, he doesn't put his hand at the back, he just throws here, he's not going to be able to throw it very far. Okay, as opposed to if you put his hand at the back. Okay, if you play football and you're the person who always throws the ball in, and you kind of know this, you need to put your hand back so that you increase the amount of time that you're putting the force on the ball. Okay, because if you just throw from here, from above the head over here, okay, then the time is very short. And we see that if your time is very short, then your impulse is going to be very short, very small. The change in momentum is very small. So you cannot go further. Okay, but if you increase the amount of time that kamu kenakan the force on the ball, okay, all the way, okay, so you're going to have this very big impulse. If you have a big impulse, you will have a big change in momentum. Okay, a big change in momentum means your final velocity will be very high. Kamu akan menambah dia punya kelajuan. Okay, if your final momentum is very high, so your change in momentum is going to be very high. Okay, therefore the ball will move with a higher velocity and it will move further. Okay, and that's why the football player, okay, throws with his hand at the back. Okay, I think anybody who plays ball, anybody who plays monkey lah, okay, with your friend, you will know this. Okay, different case than if you throw from the chest lah. Kalau macam bola jaring, okay, this is different case, but you're still doing the same thing. You're putting the amount of time onto the ball. You're putting more force on the ball with a big amount of time. Okay, big force, big time, big impulse, go further. Okay, because the change of momentum is larger. Okay, likewise, this number 8, I'm not putting the explanation here because the reasoning is still the same. Okay, a boy is riding on a skateboard. Okay, his right foot pushes the concrete floor with a strong pushing force and a long action time to push the skateboard forward. Okay, nobody goes on a skateboard. Sorry, I don't know. Do people still play skateboard nowadays? But anyway, nobody plays the skateboard and then dia punya kaki just macam tu tiada. He spends a long time. He really pushes himself forward. Okay, by spending a significant amount of time. Okay, using his big force. Okay, because force big but time short means your impulse is small. You're not going to go very far. Okay, big force and big amount of time spent to use that force is going to make your skateboard go much further. Okay, if you don't believe, if you have a garden and you're allowed to go into your garden, go ahead and try this. Okay, if you have a skateboard, try lah. Use the same amount of force but short time and long time. See the big difference. Okay, your skateboard now will go much further if you use that force with a long time. Okay, you spend more time to push the skateboard. Okay, rather than just like that lah. Okay, so this principle of the change of momentum, okay, is very important. The reason we do this is to produce a bigger change in momentum, because if there is a bigger change in momentum, then your ball can go further, your skateboard can go further. This is things that are good for us. Okay, we want this big change of momentum, because big change of momentum will ensure, that things you want to go further lah. If you don't want things to go further, okay, let's say you want things like to be near, but then either you don't push so hard or you don't push so long. Okay, because the longer time you spend, there's going to be a bigger change in momentum. Okay, and that's this part about impulse. So remember, impulse, there's two formulas to it. One is the force times with the time, and then secondly is mv minus mu. Okay, some books will write it like this: ft equals to mv minus mu, and then they say that this is the formula. Okay, I find that this is a little bit, not to say erroneous. It's not erroneous, dia tidak salah. Okay, cuma it's very misleading. Okay, I would prefer that you write it like this: impulse. Okay, equals to ft. Okay, depending on the situation they give you. If they just give you force and time, then calculate the impulse by using force and time. Okay, or the other one is impulse. I'm going to short form imp. Okay, equals to mv minus mu. Okay, I would prefer that you use these two instead of this. This is, I know, this one is we got from Newton's second law. Okay, but I want you to consider it this way, because let's say we're talking about exam questions lah. Okay, exam questions will only give you one or the other. They will give you force and time, or they will give you the final velocity, initial velocity, and the mass. Okay, so we calculate it as impulse. There, as far as I know, there is no actual symbol for impulse. That's why I use words. Okay, so impulse is ft or impulse is mv minus mu. Okay, so the two things, one is how to use the formula. Second one is the explanation itself. Okay, the point about impulse is you want the big change in momentum. Big change in momentum, ball goes further. Skateboard goes further. Small change in momentum, ball jatuh di depan kamu saja. Okay, or the skateboard just, lands like a few centimeters away from you. So we don't, I mean, depending on the situation, sometimes we want small impulse, sometimes we want big impulse or big change in momentum. All right. This is probably what is the most famous part in this subtopic. Okay, the relationship between impulsive force and the time of impact. So now we go back to the first formula that we were talking about before. Okay, let's consider this. Sorry. Okay, let's consider this formula again. Okay, we find that impulsive force equals to the change in momentum. Okay, divided by the time, the rate of change of momentum. So we find that because the impulsive force is apa yang kita panggil on top, okay, and the time is at the bottom, we find that they are seperti satu dacing. Okay, when your time increases, okay, let's assume that the change of momentum is constant. Okay, change of momentum is constant. The only difference that you can make is if you change the amount of time that is involved. Okay, we find that because we are on opposite ends like this, one is on top and one is at the bottom, we find that when the time of impact, when the time of impact increases, okay, when this increases, okay, the number that you divide becomes bigger, we find that the impulsive force will decrease. And the other way around works true. When we make this number smaller, okay, when the time of impact decreases, okay, we find that the impulsive force will increase. And this is the relationship that we are going to talk about. Okay, if you remember how to write relationship, the bigger the time of impact, the smaller the impulsive force. Or the other way, the smaller the time of impact, okay, the bigger the impulsive force. And this is very easily shown now. For example, if I'm going to hurt myself with this, but okay, if let's say I'm going to sorry, okay, I'm going to slap my hand on the wall, okay, and I'm going to do it with the same amount of force, but with the same amount of change of momentum. I'm going to try to do it, okay. But what if I do it very fast and I do it very long? If I take a very long time to do it, okay. If I'm going to slap the wall like this, okay. So my time of impact, the time that my hand touched the wall, okay. I'm going to show it to you again. Okay, so it's very short amount of time. Okay, I find that my hand feels more painful. Then, if I were to take my own sweet time okay, to do this. Okay, I find that, okay, I'm going to stop doing it because my hand is very painful. We find that, doing that one puts more hurt on my hand. Okay, if I were to do it in a very short amount of time, rather than if I take a very long time to do it. Okay, another good way is, I wouldn't recommend you to do this to anybody. Okay, for example, what's the best way to slap somebody on his face? Okay, would you slap it like very fast like that, or would you like take your own sweet time like that Okay, you find now that this is more effective because the time of impact, the time that your hand touches his face. No, I'm not going to slap my own face, please. Okay, the time that your hand touches his face is very short. Okay, and it leaves a bigger impact on the face. Then if you were to slap somebody on the face, okay, I'm not advocating violence, people. I'm just showing to you a real life example. Okay, then if you were to slap a person's face, but you leave your hand there for a slightly longer time, okay, the impact is less. Okay, because as we said, when the time of impact is very short, very fast, okay, you find that the impulsive force increases. This hand that gonna slap is gonna feel a much bigger force, more painful. Okay, then if I were to slap this person, okay, I take a very long time to touch this hand, sorry. Okay, we find that the time is so long, This guy is gonna be like, was that even a slap? Okay, it's not even a slap at all. Okay, and we find out that this relationship helps us in a lot of things. Okay, it helps a lot of scientists to determine a lot of things, especially when they're designing or when they're building something. Okay, because of this action and reaction rule. Okay, you big action, big reaction. Small action, small reaction. How do you get a big action? You make the time of impact very small. Okay, time of impact very small. Sure, you can even notice it when you clap. You try to clap with the same amount of force, but you do it fast and you do it slow. No, not slow. You do it with a longer time. Same amount of force. You find that even the sound quality is different. Yeah, I'm not sure how the sound quality is like sounding to you, but my hand is kind of feeling it now. Okay, so it's like ouch. Okay, enough. I'm done slapping my hand. So that's the relationship between impulsive force and the time of impact. The bigger the time of impact, okay, as I've shown you over here, the bigger the time of impact, okay, the smaller the force, and the other way around. Okay, a small time of impact will produce a much bigger impulsive force. Okay, which is why you find that the most damaging accidents we're going to always come back to this accident because it's the best example. Okay, we find out that accidents that happen over a very short amount of time, okay, usually does more damage to the car than if the car was being slowly macam dia kena langgar oleh satu gajah yang sangat slow. We find that the impact is much, much, much less than if he were to suddenly run into the tree, or sorry, the gajah. Okay, because the amount of time actually tells us the amount of force that is acting on the car. Okay, and we find that accidents that happen over a short period of time usually has more damage. Okay, and as I said this short period of time 0.5 seconds and 1.0 seconds is a very big difference. Okay, because of this impulsive force thing that I've mentioned here. Okay, if my time of impact is 1 second and my time of impact is 0.5 seconds, okay, the time of impact 0.5 seconds is going to deal much more damage than 1 second. To us, 1 second is like 1 second macam tu je. Okay, but 0.5 seconds and 1 second is a very big difference. Okay, in terms of impulsive force, it determines whether your car is going to be total loss or whether it's or whether it's going to be just bumper jack and rosak. Okay, we don't think about this whenever palis lah. We don't think about this whenever we see an accident. Okay, but we find that the biggest damage happens when the time of impact is very short. Okay, because the change of momentum is constant. Okay, so to my students, okay, to those of you who are in 4SA, I put this up in Flipgrid actually. I want you to research on this, okay? There's a lot of things that you can read from the textbook, but I want you to be creative. Okay, make a Flipgrid video. This is your first assignment. 3 assignments for this section. Okay, I want you to make a Flipgrid video, okay, that explains 2 things. Number 1, show me a situation where the impulsive force needs to be reduced. Okay, there are only 2. There's only 1 example that is given in your textbook, and I don't want to see that example. So the examples in the textbook tidak boleh diguna. Okay, I'm not allowing you to use that. Okay, go and research. Go and type copy this whole sentence and Google. Okay, situation where the impulsive force needs to be reduced. Okay, and the situation where the big impulsive force is beneficial for you. Okay, if you are students from other classes, ST and SC, and even from other schools, this is a good thing to go and research on. I don't have to tell this to you. Okay, I think that if you read this for yourself, and if you remember the thing that I explained before, okay, about the relationship between impulsive force and time of impact, okay, then all this is just application. Okay, which I want my own students, those of you in 4SA, I want you to do this assignment for me. Okay, and I'm going to up this a little bit more okay. Okay, so to my students who are in 4SA, okay, this time the Flipgrid assignment, I want to see your face when you explain it to me. Okay, because I think it's unfair that I'm always showing my face in YouTube. Okay, it's always there for the world to see, but in Flipgrid video where it's virtually private, you are shy to show your face. I don't think that's true. Okay, so this time when you explain it to me, tell it to me. Okay, record yourself doing it and tell it to me. Okay, explain the situation and where the impulsive force needs to be reduced. And secondly, explain the situation where the big impulsive force is beneficial. When I say explain the situation means I want you to be creative. Okay, try to find real life examples, things around you, things in the house. Okay, but please, everybody, no violence. I don't want to have 28 videos of people slapping one another. No, 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 cannot. Okay, no violence, please. If you want, you can slap a watermelon, but you cannot slap your brother or your sister's face. Okay, no matter how annoying your brother and sister might be, please, no violence. Okay, so do the situation and explain the situation to me. Why it needs to be reduced and why is it beneficial? Okay, if you have any questions, you can ask me in the Telegram group later. All right, so that's the first assignment for my 4SA students. Okay, now we're going to do a couple of exercises. So this first exercise over here, a golfer hits a golf ball of mass 50 grams. Okay, I'm going to circle all this important information at the velocity of 50 meters per second. Okay, if the time of impact is 0.005 seconds. Now, guys, this is a very small time of impact. We're going to be thinking about, we're going to think that, oh, okay, small time impact means the impulsive force is going to be very big, right? Okay, so what is the impulsive force acting on the golf ball? Okay, so we have our formula lah. F equals to mv, impulsive force, impulsive force people, minus mu over t. Okay, problem number one, our mass is 50 grams. Okay, and we have done this so many times that I think you should know this by now. Whenever you have 50 grams, tukar dulu pergi kilogram. So 1, 2, 3. So 0.05. Okay, kilogram. Okay. Secondly, you have this velocity of 50 meters per second, but you're not given the initial velocity. Okay, the time of impact means this velocity is 50, meters per second. But what is the initial velocity? Okay, think about the golf ball situation. Whenever somebody hits the golf ball, what is the golf ball doing at first? He is not moving. Okay, golf ball not moving means U equals to 0. So U equals to 0, V equals to 50, mass is 0.05 kg, 1, 2, 3, 0.05 kg, and the time of impact is 0.05. So you can actually count the impulsive force already. Okay, I don't think it will be that much of a problem, but let's try to do it lah. Okay, so thank you. All right, so F equals to mv minus mu over t. You find that the mass is 0.05, d is 50, u is 0, okay, over 0.005. Okay, so the important thing is you remember that in a situation where the golf ball, okay, the golf ball is initial velocity will be 0 lah, because it's at rest. Okay, so once you count this, okay, I'm pretty sure that you can count this on your own lah. 50 divided by 0.005. So we're going to get a force of 500 Newton. Okay. Just to give you a slight contextualization, a force of 500 newtons is about a 50 kilogram force. Okay, imagine a 50 kilogram ball or something hitting the golf ball. Okay, that is actually initially not doing anything at first. Okay, about 50 kilograms. Okay, so it's a pretty big force. Okay, 500 newtons. We find that 500 newtons, 0.005 seconds. The time of impact is so short. Okay, and if you are a golfer, then you will know that this is what we call a drive. Okay, we drive the ball through the golf course. Okay, right. Second question. Mokhtar Dahari kicks a ball with a force. Now he's giving you the force of 1,500 newtons. Okay, the time of impact is 0.01 seconds. You don't think about this, 0.01 seconds is a very short amount of time. Okay, we're no longer dealing with 2, 3, 4, 15 seconds. No, short amount of time. So what is the impulse delivered to the ball? Now, as I said, they've only given you the force and the time of impact. So let's count the impulse. Okay, the impulse is force times time. Okay, the force is 1,500, and then the time is 0.01. 0.01. Okay, so 1500 times 0.01 will give you 15. Okay, the unit for impulse, let's think about this. Okay, unit for impulse is force. What's the unit for force? Newton. Newton times second. So Newton second. Okay, if there's actually an alternative, remember, there are two definitions for impulse. One is the product of force and time. The second one is change in momentum. What is the unit for momentum? Kilogram kilogram meters per second squared. So this is the unit for impulse. This also is the unit for impulse. Dua-dua pun boleh, tiada masalah. Okay, but since we're using force times time, I'm going to use this lah. Okay, continuing the question, if the mass of the ball is 0.5 kg, what is the velocity of the ball? Okay, let's think about this now. The ball mass is 0.5 kg. What is the initial velocity? Again, before a ball is kicked, the initial velocity is 0. My question is, what is the final velocity? Okay, and this is where we use the first impulse sama dengan the second impulse. So 15 equals to mv minus mu. Okay, so 15 equals to 0.5 v minus 0.5 times 0, which is basically 0 lah. Okay, so 15 divided by 0.5 equals to v. So you find that v is actually 30 meters per second. Okay, let me see, divide by 0. Yeah, 30 meters per second. Okay, it's a pretty fast ball, 30 meters per second. 1 second you travel 30 meters. Okay, it's considered pretty fast. Okay, but this is an example of how we use both formulas. Okay, so that's why I said try not to immediately jump into this one. Ft equals to mv minus m. A lot of people get stuck. Know that you can actually separate it and join it back together. Okay, when the time is right. Okay, for example, in this case. Okay, and of course, yeah, I did mention this earlier. Don't forget that the unit for impulse is either Newton multiplied by second, or kilogram meter per second. Okay, this is the normal definition for momentum. Okay, which we have covered before. Okay, right. Let's go to the next question. Is there any more? Oh, okay, there's another one. I think there's only two more. Okay, in the tennis match, okay, a player hits an oncoming ball with a mass of 0.2 kilogram and velocity of 20 meters second squared. Okay, notice that this very kindly gives to you this negative 20 because it's going to the left. The ball rebounds with a velocity of 40 meters per second. Okay, the time taken in the collision between the ball and the tennis racket is 0.01 seconds. Okay, so everything is given over here. What is the impulse experienced by the ball? Now, guys, there is no force given over here. So we calculate the impulse by only using, I'm going to use the letter I because I'm very tired of writing the entire words. I equals to mv minus mu. Okay, but be very careful that the u is actually negative. Okay, so this would be actually 0.2 times 40. Okay, we're going to assume that 40 is to the right. Okay, minus 0.2 times with negative 20. Okay, remember, just like in momentum and everything that we have studied before this, the direction of the velocity is always very important, okay, in terms of mathematics. So 0.2 times 40 minus 0.2 times negative 20. Okay, which will give you 12. Okay, 12 what? Okay, you can use either one of the units that I given earlier, but since over here we're talking about change of momentum, I'm going to write this as 12 kilograms meter per second. Okay, so what is the impulsive force exerted on the tennis ball? Okay, which we have calculated before. F equals to mv minus mu over t. And we have just calculated the impulse, which is 12. So the impulsive force is 12 over 0.01. Okay. So this is another example of use for, for impulsive force. Okay, you want to hit the ball with the shortest amount of time possible so that the ball can go far. Okay, so 12 divided by 0.01 is 1,200 newtons. 1,200 newtons is a very big impulsive force. Okay, 1,200 newtons. Okay, so actually the calculation part of this is very simple, I find, because it's a very straightforward formula. Just don't forget that the V and the U is actually apa itu? It's actually the direction of V and U is very important. Okay, don't forget this. All right, I think this is probably the last question. Is this the last question? Let me see. Oh, yes, it is the last question. Okay, so we have this guy, Ali. He's a mass 60 kilogram, jumps from the first floor of the burning house. Okay, I know this picture is an exaggeration. This is the first floor, but never mind. Okay, now his velocity just before landing on the ground is 6 meters per second. Okay, now this is something that I don't recommend anybody would do unless your house is burning. Okay, if your house is burning, please don't, jangan pergi cari pasal and then just jump out of the window, just because you want to test and see lah. But okay, let's see. Calculate the impulse, okay, when his leg hits the ground. Now, first ask yourself, did they give you the force? No. Did they give you anything else? No. They just give you the mass and the final velocity just before landing on the ground. So obviously, we have to use the other side of the impulse formula. Okay, impulse, okay, equals to mv minus mu. Okay, so his mass is, let's check, is the mass 60 kilograms? Yes, it's 60 in kilograms. So mv 60 times 6. Okay, I'm going to write this as negative 6 because all this while we've been talking about downwards as negative. Okay, so don't worry about this. Okay, minus 60 times 0. Okay, so we're going to get the impulse of negative 360. And then what are we using here? What's the unit? Okay, this will be kilograms meters per second. Okay, denoting that the impulse is downwards. Okay, to the force is acting downwards. Don't worry about it. Okay. So what is the impulsive force on the resident's legs if he bends upon landing and takes 0.5 seconds to stop? Okay, I'm going to stop here and I don't know how I'm going to demonstrate this to you. Okay, so for example, if you're going to fall, if you're going to jump off the building, okay, let's say this is the floor. Okay, when you land, and even gymnastics, we see people doing this. Okay, there are two ways to land. One is if you land and your legs are very lurus as you can. Okay, or the other one is if you jump and then you land with your legs bent. Okay, now if you have done gymnastics before, the actual rule is you cannot bend your legs. The less you bend your legs, the higher marks you get. Okay, but in reality, actually it's very dangerous. Imagine if you're jumping from the first floor, and then when you jump, like that, you just straight legs. Okay, what's going to happen to you? Is your legs are going to feel all the impact of the force, because the time of impact is very short when you straighten the legs. So you bend the legs to increase the time of impact. Okay, I'm not saying that your legs may not get broken now, but at least you reduce the amount of force that is acting on your legs. Okay, so guys, whenever you feel like you're jumping on this one, okay, I know rules are rules, okay, and I know that in competition you have to follow the rules. But let's say if you're jumping in a normal situation, don't forget to bend your legs. Leg straight, like that. Because every jump is a force on your knees. Okay, and the first thing to kena will always be the knee. Always bend your legs and jump. Okay, so anyway, coming back to this. this thing. So what is the impulsive force? Okay, impulsive force is the impulse divided by the time. So F equals to the impulse is negative 360. Okay, divided by time 0.5. Okay, let's calculate this. 360 divided by 0.5 is negative 720 newtons. Okay, negative 720 newtons is pretty small. It's about 70 kilogram kind of force. Okay, imagine 70 kilograms to hempap kamu. Okay, that's the force of 720 newtons. Now, what is the impulsive force on the resident's legs if he does not bend? And because he's not bending, his time of impact is going to be much faster. He's going to land and be more stable much faster. Okay, 0.05. Let's calculate. F equals to negative 360 divided by 0.05. Okay, what you're going to get is you're going to get a negative 720, no, negative 7,200 newtons. Okay, negative 7,200 newtons. Okay, is about a 700 kilo. Okay, so the first one now when he bends his legs, okay, is like a 70 kilo bag falling on you. But the second one now when you don't bend your legs, okay, and you shorten the time of impact, you have a 700 kilo, okay, bag falling on you. Your legs are going to feel the force of 700 kilos. Okay, now if this is not made clear, let me explain to you this. When you bend, okay, I know, okay, when you bend, sorry, when you land on the ground, let's say this is the ground now. Okay, so you are putting a force of, let's say like this, negative 720, okay, newtons onto the ground. Okay, this is what you're doing. Now remember what Newton's third law says. For every action, there is an equal and opposite reaction. So the ground is going to push back at you with 720 newtons, okay, upwards. Okay, and who is going to feel the force? You are going to feel the force. More specifically, your knees lah. Okay, kamu punya lutut yang akan rasa. Okay, the force. Okay, so that's why you bend your legs, people, so that the force is less. I'm not saying the force is going to be gone. It's definitely going to be there because you're falling. Okay, but if you don't bend your legs, let's say kamu, sorry, this is bent. This is not supposed to be bent. Okay, let's say you land with super straight legs like this. Okay, so okay, you are going to feel, you are going to mengenakan a force of negative 7,200 newtons onto the ground. Okay, and then Newton's third law says the ground is going to fight back. The ground is going to give you back, okay, 7,200 newtons, okay, because of Newton's third law. The reaction is there. And who is going to feel this 700 kilos? Is you, Okay, if you think that landing with your legs straight is very glamorous, right? Okay, just think lah. Would you rather be slapped in the face with a 70 kilogram bag or a 700 kilogram bag? Okay, this is about 70 kilos lah. Okay, the force about lah. Okay, this is 700 kilo. Cuba kau bayangkan kalau orang tampar muka kamu kan dengan 700 kilogram. Okay, you know how painful that will be? Okay. So guys, I know I keep saying this, but please, okay, of course the number one advice is don't jump off a building lah. Okay, I'm not encouraging you to jump off a building. But if you have to jump, people, okay, don't be so hero and jump with your legs straight. Okay, I sometimes get very worried when I see our cheerleaders when they do all these amazing stunts and then they land with their feet straight like this, Wow, my goodness. Okay, baru 16 tahun kan, already got knee problem. It's not the way to go. Okay, you want to bend your knees. Okay, you want to bend your knees because the advantage of bending the knees upon landing is you feel a less reaction force from the ground. Okay, the impulsive force on Ali is less when he bends his legs upon landing. Okay, I'm going to repeat the answer for D. The impulsive force on Ali, okay, the impulsive force on Ali, okay, is going to be less when he bends his legs upon landing. Why is it less? Why is this impulsive force less? It's because remember, he is putting negative 720 newtons onto the ground. Newton's third law says that whenever you do an action, there is going to be a reaction. So the ground is going to push back with the same amount of force. Okay, this one you can control. This one you cannot control. However much you give to the ground is going to give it back to you. Okay, macam buat baik dibalas baik, buat jahat dibalas jahat, things like that. Okay, the same amount of action is going to cause the same amount of reaction. That's what Newton's third law teaches us. Okay, and this law has become so important to us. Whenever we think about accidents, whenever we think about designing cars, whenever we think about designing anything, okay, designing rockets, spaceships, planes. Okay, this concept is very important to us. We want to increase. There are situations where we need to increase the impulsive force, and there are situations like this, okay, where we need to decrease the impulsive force. Okay, and we do that by changing the amount of time. We change the time of impact. Remember, smaller time of impact, okay, 0.05 seconds, is going to give you a much bigger impulsive force. It's not good for you in this case. A bigger time of impact is going to give you a smaller impulsive force, okay, which in this situation is good. So I want you to think of our time of impact as very short. Both are very short. Okay, tapi sekarang dia punya perbezaan is 0. Decimal places. We're not talking 10 seconds and 20 seconds of time of impact. This is too long already. Nobody crashes into a car for 20 seconds, please. Okay, more like 0.002 seconds. That one is a crash. Okay, so when we talk about impulsive force, remember it is a force, okay, that is acting and reacting in a short amount of time. Okay, and we need to think of ways on how to reduce or increase the impulsive force when the situation is useful. Okay, I think that's all I have for today. This is a pretty simple subtopic. I hope it has been useful. But I just want to end by showing again, not again, okay, showing to my own 4SA students. So those of you from 4SA, please take note of this. I've given 2 assignments for you. Okay, one is a written exercise that is that you can look at in your textbook. Okay, just 2 questions, and then do the same thing. Please upload it into PDF. Okay, and then upload it into the Google Classroom. And then the second one is a Kahoot quiz. Okay, the Kahoot quiz is as normal. So for this subtopic, people, you have 3 assignments. 2 are from Google Classroom, and 1 is the Flipgrid assignment. Okay, but the Flipgrid and all the due dates, I think, are the same. Let me see. The due dates are this Friday. Yeah, today is the 14th. Everything must be handed in by this Friday, because this Friday I want to talk about something else. Okay, this Friday we're going to finish this chapter, but after that next week we will talk about something else. Okay, so for those of you who are in 4SA, please remember you have 3 assignments. Okay, you have 3 assignments, and I want you to finish all 3 of them by this Friday. Okay, thanks everyone for coming today. I hope it has been useful. I don't see any questions that anybody is asking, so I hope that everyone understands. But if there's something that you want to ask, you can always PM me or ask in the group. Okay, so thanks for watching, everyone. Take care, stay safe, stay healthy. I'll see you all on Friday at the same time, Friday at 2 p.m. Okay, bye.